Greetings of the day, dear students. Today in this class we are going to discuss about the polar and rectangular form representation, where we are going to discuss about the phasor notation or representation, right? And we will see what about its magnitude and phase, and similarly we will discuss the rectangular form, polar form, and exponential form. And slowly we will express the given sinusoid in the form of a phasor. How to express the given sinusoid in the form of a phasor, and we will see the phasor diagram representation, and we will find out how to draw the phasor diagram for a given mathematical form, and we will do some calculations, right? Yeah. Most of the times these steps are important while doing or solving some of the problems. All these basics you will be applying while solving the problems. Coming to the definition of a phasor, it is nothing but a complex number that represents the amplitude and phase. These 2 points are important. It just simply represents the amplitude and phase of a sinusoid, right? But in the previous discussions, a sinusoid, it can be either sine wave or cosine wave, right? And for example, if it is of the form, for example, a voltage waveform V of t equals to Vm cos of omega t plus phi, this is a sinusoid, right? So we will represent this sinusoid in the form of a phasor. Now the complex number, which is a number z, which will be in a rectangular form, with this complex number we are already familiar. Z equal to x plus jy, or in some textbooks or notations they will follow I, x plus iy, right? Yeah, where this x represents the real part of z, that x is the real part of z, and y is the imaginary part of z. Y is what? Y is the imaginary part of the z. Now, if we express this complex number in polar form, right, we can write it in the form of r at an angle theta. Very, very important, dear students. We can express it in the form of r at an angle theta, or r into e power I theta. Clear? R into e power I theta. That is also okay. Now, what will be the value of r? That is nothing but simply the magnitude of z. Already we know z. What is this in complex form? X plus iy. The mod z is given by root over x square plus y square, and the angle theta is given by tan inverse of y by x. These two parameters are very, very important. Magnitude of z is given by root over x square plus y square, and theta is given by tan inverse of y by x. If you observe, on x-axis if you have taken the real axis, and y-axis you have taken the imaginary axis, right? And this x, the magnitude r at an angle theta. What about cos theta? Adjacent side by hypotenuse, but the adjacent side length is x. The hypotenuse length is r, x by r. From this what we can say? X equal to r cos theta. This is also very, very important. X equal to r cos theta. And similarly, dear students, sin theta equal to opposite side by hypotenuse. What is opposite side length here in this diagram? Y. Y divided by r. So y equal to r sin theta. Y equal to r sin theta. So what we can conclude is, these are the three important forms. If you have written the complex number z in x plus jy format, then it represents a rectangular form. It represents a rectangular form. If it is written in the form of z equal to r at an angle theta, r at an angle theta, then it represents a polar form. If it is written in the form of z equal to r into e power I theta, then it represents a exponential form. It represents a exponential form. Clear? In this context, what about r? Just now we have seen r equal to nothing but the magnitude of z square root of x square plus y square we have to take. And theta is tan inverse of y by x we have to take. Right? Yeah. Now, what will be its complex conjugate? Z star. Z star, the complex conjugate Z star, and Z equals to x plus iy, and its conjugate is x minus iy. So r at an angle minus theta. We can write it in the form of r into e power I theta. R into e power I theta. But from basics we know that e power plus or minus I theta, e power plus or minus I theta is equal to cos theta plus or minus I sin theta. If you observe, what is the cos theta? Is nothing but the real part of, it is the real part of e power I theta, right? And sin theta is the imaginary part of e power I theta. Sin theta is the imaginary part of e power I theta. These basics are important here, students. E power I theta, cos theta plus I sin theta. E power minus I theta, cos theta minus I sin theta, cos theta minus I sin theta. Now, after knowing this rectangular form, polar form and exponential form, now we will discuss about the how to express the sinusoid as a phasor. As a phasor. Again, if you recollect the definition of a phasor, it represents the what? Amplitude and phase. It will not speak about the frequency. It will not speak about the frequency of the sinusoid. So it just simply represents the only amplitude and phase. Clear? Yeah. Now let me see. For example, a sinusoid is given v of t equal to Vm cos of omega t plus theta. How we can write this? If you observe, this is nothing but the real part of, only just the real part of e power, real part of e power I theta. E power I theta, how we can write it? Cos theta plus I sin theta, right? So in the after expanding this e power I theta, of that only if the real part is considered, that is nothing but the Vm cos of omega t plus theta. Clear? Right. Now some e power I, just to expand that, anything, some a power, some x power m whole power n is, oh, not this one, sorry. Just expand 1 second. E power some m plus n format, e power m into e power n, e power m plus n. Just we have expanded this one, right? Now just let you bring out Vm term towards e power I theta. This frequency term omega t represents the frequency term. You just separate that. E power I omega t represents the frequency term. Just bring out only amplitude and phase theta. Sin omega t plus theta. Theta there represents the phase, right? Just bring out only amplitude and phase. Vm into e power I theta. Now this Vm into e power I theta, this is what we will represent with some capital letter V. We will represent this Vm into e power I theta with some capital letter V, which represents the phasor. Phasor of the given sinusoid of the mathematical form Vm cos of omega t plus theta. Vm cos of omega t plus theta. So then somewhere if you see Vm cos of omega t plus theta, now we can write its phasor capital V equal to Vm at an angle theta. This is the representation of the sinusoid phasor, right? That is simple. For example, somewhere if I have given like this, V of t equal to 110 cos of omega t plus 10 degrees. Now your capital V will be simply 110 at an angle. What is the angle theta? 10 degrees. 110 at an angle 10 degrees. So this is the sinusoidal representation and this is the phasor representation. This is the phasor representation. 110 at an angle 10 degrees. Clear? Yeah. Now this behaves as a vector. This phasor has magnitude. It is having both magnitude and phase, right? And this phasor analysis, this point is very important, dear students. This phasor analysis applies only when frequency is constant. Only when frequency is constant, right? So it will not speak anything about the frequency. This is the applies only when the frequency is constant. Now let me come to the graphical representation. How to represent? So this is very important in various subjects and different subjects also. You are supposed to draw the phasor diagram. Phasor diagram in transformers also, and in different concepts you will come across this phasor diagram. The thing is, in a simple manner I will tell you. You just simply take a, you are having two axes. Understand, if it is 5 at an angle 30 degrees, first case, and the second case 5 at an angle minus 30 degrees. If you want to draw this in the form of a phasor diagram, phasor representation, you observe whether the angle is magnitude wise, everybody will take the same length. A line of length some 5 centimeters or 5 units they will take, not a problem. And this is real axis, and this is some imaginary axis, let it be, right? Plus 30 degrees. If it is plus 30 degrees, please rotate in the anti-clockwise direction. This is reference with 0 degrees. So this is 5. This is the first case. For first case it looks like this. Length is 5. Angle is 30 degrees. Very simple. If it is 5 at an angle minus 30 degrees with reference to the origin, okay, you just simply rotate in the clockwise direction, minus 30 degrees. Same here, you draw like this. Now here the length is 5 units, okay, and this angle is minus 30 degrees. Clear? Very simple. If you understand this basic, so many diagrams we can draw very easily. I repeat again, dear students, if the magnitude wise not a problem, 5, you will draw a line of length 5 units. Angle, observe the angle whether it is plus 30 or minus 30 or some other angle. If it is plus, you please rotate in the anti-clockwise direction. Anti-clockwise direction. Positive. This is what very important. If it is negative, please rotate in the clockwise direction. Clockwise direction. Then easily we can draw the phasor diagram. That is what we have done here. Now V equal to Vm at an angle theta. This is the phasor representation, and this is the diagram. So you have drawn a line of length Vm units and at an angle theta. I equal to Im at an angle minus theta. Now you have drawn a line of length some Im units, right, at an angle minus theta. You have rotated in the clockwise direction, right? Yeah. Now observe, one more important point I will tell you here. So with respect to this one, the angle is 30 degrees, where if you are rotating in anti-clockwise direction. But for the same 5, right, uh, this 5 at an angle 30 degrees is also same as 5 at an angle minus 330 degrees. Very, very important. This is also same as 5 at an angle minus 330 degrees. Out of 360, you just simply subtract the 30 degrees. 360 minus 30, 330. That means, for example, the length is 5, but the angle is how much? This angle. With reference to if you are rotating in this direction, now this angle is minus 330 degrees. That is the meaning. Clear? For both the things, if I ask you to draw the phasor diagram for 5 at an angle minus 330, the same diagram you will get. You won't get two different phasor diagrams for 5 at an angle 30 and 5 at an angle minus 330. Both the things will have only one diagram. Similarly, one more example. 5 at an angle 60 degrees diagram will be same as 5 at an angle minus 300. Both the diagrams will be same. Both the diagrams will be same, right? Yeah. That is one important point. Now, V of t equals to Vm cos of omega t plus theta. We are simply representing it in the form of Vm at an angle theta. Now, this is called the phasor domain representation, and this is called the time domain representation. Time domain representation. Clear? Now, somewhere you have seen V of t equal to Vm cos of omega t plus theta. We are writing it in the form of Vm at an angle theta. Fine, good. But if we see Vm at an angle sine of omega t plus theta, then it is to be written as Vm at an angle theta minus 90. This is very, very important. This is where most of the students are committing the mistake. You should be cautioned at this point. What it means is, for example, V of t equal to some 5 cos of omega t plus 10 degrees. Now its phasor is capital V equal to, what is Vm? 5. What is angle theta? At an angle 10 degrees. This is okay, good. But if I ask you V of t equal to 5 sine of omega t plus 10 degrees, then also most of the students are writing its phasor as capital V equals to, they are not looking whether the term is given cos of something or sine of something. That is important. If it is cos term, then only you should write Vm at an angle theta. Very, very important. Please focus. If it is sine of omega t plus theta, then what we will get here? 5 at an angle. What is already theta? Theta is 10 minus 90 degrees. So its meaning is 5 at an angle minus 80 degrees. This is what you have to write. 5 at an angle minus 80 degrees. Clear? Yeah. For example, if it is given in terms of sine, you express in terms of cos. Then it will be easy for you. You bring in the generalized form of cos. I will tell you one example. You will understand it clearly. This is where more chances for committing the mistake. The moment you see 5 sine of omega t plus theta, if phasor is asked, it is not it is not 5 Vm 5 at an angle 10 degrees, then your answer will be wrong. Observe, it is sine term given. Clear? If it is cos term given, no doubt, this generalized form is Vm at an angle theta. Vm at an angle theta. Yeah. Now, observe the sinusoid V of t equal to 5 cos of omega t minus 20 degrees. 5 cos of 314t minus 20 degrees. What is its phasor representation? This is in the form of Vm cos of omega t plus theta. So its V will be 5 Vm at an angle theta. In the place of theta we are having minus 20 degrees. So 5 at an angle minus 20 degrees. While drawing the phasor diagram, magnitude is 5 units. Good. What about angle? Plus theta or minus theta? Minus theta. Clockwise or anti-clockwise? Clockwise. That is the reason you will get that graph in which quadrant? You are getting this in the first, second, third and fourth. You got the graph in fourth quadrant. You got the graph in fourth quadrant. The angle is minus 20 degrees. Clear? Yeah. Now let me express V of t equal to minus 5 sine of 314t minus 20 degrees. Immediately looking on this, you should not write like this. Vm is minus 5, angle is minus 20 degrees. This is wrong. Why it is wrong? Because the term given here is sine. You express it in terms of cos term. How we will do that? What about minus sine theta from trigonometric basics? Minus sine theta is nothing but cos of 90 plus theta. Most of the students will feel difficult here. If I ask cos 90 plus theta, they will tell me answer immediately. Cos 90 plus theta minus sine theta, they will tell. If we ask minus sine theta, it is taking some time for them, right? Yeah. Minus sine theta, nothing but cos of 90 plus theta. Clear? That is what we will do here. Minus 5 sine 314t minus 20 is the same as 5 times cos of this angle is same. Just you simply add 90 degrees for that term. For this term, you just simply add 90. How much we will get? This term is same as now 5 cos 314t plus 70 degrees. 314t plus 70 degrees. Now we got our general form. This is in the form of Vm cos of omega t plus theta. Once you got this general form, if phasor representation is asked, it is very simple. V equal to Vm at an angle theta, right? Now Vm is 5, theta is 70. Its answer is 5 at an angle 70 degrees. Very, very important. Its answer is V equal to 5 at an angle 70 degrees. Clear? Yeah. Now, while drawing its diagram, in which quadrant we will get the graph? Magnitude is 5. Okay, good. What about angle? Plus theta. With reference to the 0, you please rotate in which direction? Anti-clockwise direction. Because the angle is plus 70 degrees. From here, you just measure 70 degrees and draw the graph. In which quadrant you got the graph? In first quadrant you got the graph. Clear? If you do this example, most of the doubts in your mind will get solved. Please do this example. Please do this example in your notes. Understand, this basic is very, very important. This is what I have written here. Up from this point to this point is very, very important. If any sine term is given, express in terms of cos, then only express. Clear? Yeah. Now let me see quickly some calculations, how to do this polar to rectangle and rectangle to polar calculations, dear students. If most of the times, right, Z1 equal to, yeah, these type of calculations in a number of problems you will be using. Dear students, please observe, if two complex numbers are given, Z1 equal to 2 plus J3 and Z2 equals to 4 plus J5. Now these four operations are to be performed. One is the addition, the second one is the subtraction, third one Z1 by Z2, and third one is the Z1 into Z2. Clear? Now addition and subtraction are convenient in a direct complex form itself. If it is division or multiplication, you please express them in terms of r at an angle theta, polar form. Polar form will be convenient for you. Whenever we come across some division or multiplication, right, the polar form will be simple. Why? Because means, for example, somewhere if you have seen the division of two polar numbers, that is r1 at an angle theta 1 whole divided by r2 at an angle theta 2. The answer is simple. What we can do? R1 divided by R2 at an angle theta 1 minus theta 2. This is one important basic. Similarly, if it is multiplication, R1 at an angle theta 1 multiplied with some R2 at an angle theta 2. What will be the answer? The magnitude will be R1, R2, but the common mistake, don't multiply the angles. If it is division in polar form, here the angle will be the difference. If it is multiplication in polar form, the angle will be theta 1 plus theta 2. This is very, very important, dear students. These two. That is what we have written here. R1 at an angle theta 1 divided by R2 at an angle theta 2 is same as, or its answer will be R1 by R2 at an angle theta 1 minus theta 2. Now we will see step by step. Now, for convenience sake, just express Z1 in terms of R at an angle theta. R at an, what will be the R? Magnitude is square root of x square plus y square, 2 square plus 3 square. R1 is 3.6055. Angle theta, if Z1 equals to some x plus jy, R is nothing but its magnitude, square root of x square plus y square. Now angle theta is tan inverse of y by x. That is what we have done here. In the place of y we are having 3, in the place of x 2, so that is the angle 56.309. Clear? Now 2 plus j3 in complex form is same as 3.6055 at an angle 56.309. Similarly express z2. What is z2? 4 plus j5. z2 is 4 plus j5. R2 square root of 4 square plus 5 square, 6.403. Theta 2 tan inverse of y by x, 5 divided by 4, 51.340. So 4 plus j5 is same as 6.403 at an angle 51.34. Now what we have done? We have expressed z1 and z2 in terms of r at an angle theta format, polar form. Complex form is converted to the polar form, right? Yeah. Now let me do the addition. Let me see addition of two complex numbers, 2 plus j3 plus 4 plus j5. 2 plus 4, directly we can add 2 plus 4, 6 plus j3 plus j5, j8. Very simple, right? Now you express this in r at an angle theta format. If somewhere in the problem, if you want to use in r at an angle theta format, you just find out magnitude is square root of 6 square plus 8 square. You will get 10. Angle is tan inverse of 8 by 6. We will get 53.130. Right? So this is the answer for Z1 plus Z2. Now Z1 minus Z2, 2 plus J3 minus of 4 plus J5. 2 minus 4 minus 2 we will get, J3 minus J5 minus 2J we will get, and express it in the polar form, r at an angle theta. Third one, Z1 divided by Z2. While doing division and subtraction, division and multiplication, you first write its polar form. Z1, R1 at an angle theta. This is the Z1 polar form. Z2 polar form, R2 at an angle theta 2. This is Z2 polar form. Now its answer will be R1 divided by R2 at an angle theta 1 minus theta 2. This is very important step, dear students. Magnitude you divide, but angles you don't divide. This is a common mistake where most of the students will commit. Don't do the division of the angle. Numerator angle minus denominator angle. 56.309 minus 51.34. We will get 4.969. If you want to express it in the complex form also. Because you know R, how to do this? R at an angle theta, what will be the x term? X equal to R cos theta. What will be the y term? Y equal to R sin theta. Like this you can do. Very simple. If you know R at an angle theta, if you want to write it in the form of some x plus jy, x term is nothing but x equal to R cos theta. You know R, you know theta. You just find out R cos theta, and you want to find out y, so simply take y equal to R sin theta. You will get the y term. You write it in the rectangular form. Clear? Yeah. Now multiplication, R1 at an angle theta 1. This step is very important. This is very important. R1 at an angle theta 1 into R2 at an angle theta 2. Magnitude wise it will get multiplied, but angle it is to be added, theta 1 plus theta 2. So that is what we will do here. 3.605 into 6.403, you will get 23.0860. These two angles 56 and 51 add 107.649. Now this is in the form of some other R at an angle theta. You want to write it in the form of some x plus jy format. Now this x will be R cos theta and this y will be R sin theta, and you bring it back again to the complex form. You bring it back the answer again to the complex form. Clear? Yeah. Now one more thing is, for example, Z1, Z2. Therefore, the final answers are Z1 plus Z2 equals to 6 plus J8. Z1 minus Z2 we got as minus 2 minus 2J. Z1 by Z2 0.5608 plus J 0.0487. Z1 into Z2 minus 6.399 plus J 21.99. This is how we have to do the transformation. Clear? Dear students, out of this entire calculations part, simply to say addition and subtraction, you do it in complex form directly, not a problem. It will be easy for you. If it is divisions or multiplication, you first convert them into r at an angle theta format. While division, take care that magnitude is r1 by r2, but angle is theta 1 minus theta 2. If it is multiplication, magnitude will be r1 r2, no doubt. Angle will be theta 1 plus theta 2. Clear? While drawing the phasor diagram also, please look whether the term given is cos of omega t plus theta or sin of omega t plus theta. In this entire discussion, this part is important. V of t equal to Vm sin of omega t plus theta is same as in a phasor representation. Vm at an angle theta minus 90 degrees. Take care at that point. Now this is called the phasor domain representation, and this is called the time domain representation. Another important point is if it is plus 30 degrees, rotate in the anti-clockwise direction. If it is minus 30 degrees, for example, you rotate in the clockwise direction. That is one more important point. Another important point is 5 at an angle 30 is same as 5 at an angle minus 330 degrees. Very, very important. Or 5 at an angle 60 is same as 5 at an angle minus 300. You just simply out of this angle you subtract minus 360. You will get the answer. And in phasor analysis, it is only applies only when the frequency is constant. Only when the frequency is constant. These are all the some of the important basics we have seen. Okay, thank you.